The 19th of May 1942. Early morning fog clings to the Dorset hills around Bovington camp. A row of tanks sits idle on the proving ground, motionless forms of steel under the pale light. Dew glistens on their riveted sides. The air smells of oil, cordite, and wet earth. Technicians in brown overalls move between vehicles carrying spanners and clipboards. From a distance, the tanks seem nearly identical, but one stands apart, broader, taller, slower in its movement. Its thick plates reflect no shine. Its name, stenciled in white paint across the glacis, reads A22 Churchill. The engine coughs to life with a deep, uneven rumble. Blue smoke drifts low across the field as the massive vehicle lurches forward. Observers note the way its tracks press deep ruts into the mud, its forward motion deliberate and heavy. The gearbox whines as the driver shifts into second. The Churchill advances only a few meters before halting again, steam hissing from its side vents. The smell of overheated oil mixes with exhaust. On the observation stand, two officers speak quietly. One notes the speed, barely 15 miles per hour. The other remarks on the armor thickness, 4 inches at the front, 2 on the sides. In comparison with the faster American M3 or the German Panzer IV, it appears antiquated, almost primitive. A training officer writes in his notebook, too slow for field maneuver. Unsuitable for modern mobile war. Yet the scene reveals something subtler. The Churchill's suspension compresses evenly across uneven ground. The tank climbs a ridge of wet chalk without slipping. Where lighter machines sink or lose traction, the Churchill crawls upward, steady, relentless. Its low gearing and torque seem to ignore obstacles. At the crest, it pauses, then descends without stalling. The engine note changes, low and confident. Nearby, engineers remove a panel from another vehicle's hull. The inner walls show welded reinforcement unlike earlier British designs. The tank's side armor folds down to allow easy track replacement, a field innovation introduced after early failures in deep. Mechanics measure wear patterns along the bogies and record them. Every movement feels methodical, as if the machine is being quietly redefined under observation. At the far end of the field, a damaged Matilda tank sits abandoned, a reminder of older doctrine. Its narrow tracks and weak suspension made it obsolete in North Africa. The Churchill, by contrast, looks almost agricultural, built for persistence rather than elegance. Even its gun, a short 2-pounder, seems unimpressive. But the engineer's focus is on endurance, not appearance. They count minutes before overheating. They test slope gradients. They calculate recovery time between maneuvers. Inside the control shed, a clock ticks above a map of North Africa pinned to the wall. Notes from field reports in Libya and Tunisia mark areas where armor failed to reach hill positions or cross wadis. These failures fuel the British War Office's interest in the Churchill's power-to-weight ratio. Engineers from Vauxhall Motors have brought design updates, stronger gearbox housings, improved fuel injection, wider track shoes. Each modification recorded on stiff paper with pencil annotations and red ink corrections. By late afternoon, sunlight cuts through the haze. The Churchill is parked again, its sides streaked with mud, its tracks coated in white chalk dust. A mechanic wipes grease from his hands and closes the engine hatch. On the ground beside him lies a small metal plaque stamped A22, heavy infantry tank. Few outside this proving ground yet realize that the slowest tank in Britain's arsenal will soon become its most durable, its most adaptable, and, to those facing it on the battlefield, its most feared. February 1943. Northwest Tunisia. The ground near Hunt's Gap is soaked from weeks of rain. Allied convoys move slowly through red clay tracks that collapse under their own weight. Every jeep and half-track leaves a wound of churned mud. From the ridgeline, a column of Churchill tanks descends, heavy, deliberate, moving in pairs. Their exhaust smoke blends with morning mist. The sound is not fast or rhythmic like a panzer column, but deep and continuous, like the growl of machinery under strain. An officer of the North Irish Horse watches through field glasses. His name, recorded later in a war diary, is Major John R. Eakin. He marks the slope angle, 40 degrees, and the surface type, wet clay and stone. According to his notes, the Churchills reached the crest in less than 3 minutes. A Sherman, lighter and faster, stalls halfway up, its tread spinning uselessly. The contrast is undeniable. The slower tank has outclimbed the quicker one. On the ridge, engineers follow in Bren carriers fitted with spares. They record coolant temperature, revolutions per minute, and pressure readings. The Vauxhall-built Bedford engine runs hot but steady. At 1,500 rpm, it maintains forward motion even when one track loses traction. The torque curve, low and broad, gives the Churchill its strange advantage: it never hurries, but it never stops. By afternoon, enemy mortar fire begins to fall near the valley floor. The Churchills advance again, traversing broken rock and shell craters. Shrapnel clangs off the hull with dull metallic thuds. Infantrymen follow behind, using the tank's massive shape as mobile cover. The crews inside hear only the muffled echo of impacts through layers of steel and padding. A gunner calls out bearing and elevation, the 6-pounder cannon answers with a short, heavy recoil. The shot passes through a stone wall and detonates behind it, invisible target, recorded only as a distant flash. At headquarters, observers compare reports from previous engagements in Dieppe and El Alamein. The Churchill's slowness, once seen as failure, now appears as persistence. In urban streets and steep terrain, the tank's weight and traction give it near invulnerability. It can cross trenches 10 feet wide. It can climb obstacles up to 4 feet high. German units at Longstop Hill call them Klettenfestungen, climbing fortresses. Inside one of the tanks, Sergeant Alan M. King notes fuel usage on a clipboard, 1.2 miles per gallon. A number both absurd and accepted. Each vehicle carries auxiliary cans strapped to the rear, enough for 50 miles of combat operation. The crew wears oil-stained overalls and speaks only when necessary. Their world is vibration, smoke, and confined heat. When the engine idles, the floor plates tremble under their boots. During a post-action inspection, a Churchill returns with over 60 shell strikes along its hull. None have penetrated. Mechanics count dents, replace one damaged bogie wheel, and send it back into service within hours. The armor, rolled homogeneous steel, up to 102 mm thick, has done exactly what designers intended. German reports later confirm the effect. Panzer Grenadier units are instructed to avoid close combat with Churchills and instead call for 88 mm guns or air support. At dusk, the field quiets. The Churchills are parked in a row, silhouettes black against the orange horizon. The crews climb out, faces grey with dust and exhaust soot. One tank's engine still ticks as it cools. In the stillness, the slowest machine on the field has done what speed could not. It has endured terrain, enemy fire, and time. From command notes filed that evening, A-22 performance satisfactory. Recommend continued production and adaptation. Mechanical reliability high. Armor effective. Speed acceptable given survivability. The officers sign the document in pencil. The ink will fade, but the data will not. The transformation of Britain's slowest tank is no longer theory, it is evidence. June 1944. Portsmouth Docks. Rows of Churchill tanks wait on the quayside under overcast skies. Salt mist covers the decks of landing craft as cranes lift one vehicle after another into position. Each tank bears a white Allied star and a faint smell of diesel mixed with sea air. Dock workers mark hull numbers in chalk: Churchill Mk7, 78mm gun, serial 34792. The figures tell a quiet story of industrial redirection. Between 1941 and mid-1944, Vauxhall Motors, Birmingham Railway Carriage and Wagon, and Leyland Motors have produced more than 5,600 Churchill tanks across multiple variants. Designations range from Mki with a 2-pounder gun to Mk7 with a 75mm cannon and thickened frontal armor. Production tables filed with the Ministry of Supply show incremental improvements every quarter, each small adjustment driven by battlefield reports rather than theory. Engineers record new field requests: deep wading exhausts for beach landings, side doors for infantry egress, flamethrower conversions for fortified positions. These are not speculative prototypes. They are standardized under the Churchill Crocodile and AVRE designations, shipped to Normandy in June. Data sheets from the War Office, Serial 12 Tank Sh-44, note that 240 of these specialized variants are prepared before D-Day. In the controlled logic of British engineering, the Churchill becomes less a single tank than a platform. Its interior volume, originally criticized as inefficient, allows reconfiguration: bridging gear, petard mortars, flamethrower tanks, demolition spigot guns. Mechanics can swap modules without altering the core chassis. Where other armor designs chase speed, this one evolves by persistence. At Lulworth Gunnery Range, ballistic trials continue in parallel. Steel plates salvaged from damaged tanks are tested under 88mm and 75mm impacts. Results, dated April 1944, show that the Churchill Mk7 resists penetration at 800 meters. The report concludes, hull integrity exceptional. Welding seams intact. Crew survivability, high. In the same month, fuel consumption records confirm operational endurance, an average of 90 miles on full load, with engine replacement intervals at 2,500 miles, nearly twice the lifespan of a Sherman engine under comparable stress. The Churchill's slow, over-engineered powertrain has become its shield. Across the Channel, reconnaissance photos from Caen show Churchills moving through rubble and cratered streets. German analysts misidentify them as new heavy tanks due to their silhouette and armor profile. The reality is simpler: the obsolete design has outlived its critics. At the Vauxhall Design Office in Luton, draftsmen compare revision diagrams. The earliest A-22 blueprint from 1940 lists a maximum climb angle of 25 degrees, the 1944 version 35 degrees. Ground pressure has been reduced through widened tracks, from 16 to 12 psi, a technical achievement for vehicles exceeding 40 tons. Memos filed to the Directorate of Tank Design describe consistent field reliability under all-terrain conditions. One engineer, unnamed in the surviving documents, adds a penciled note in the margin: speed irrelevant when the enemy cannot stop you. Back in Normandy, this principle is tested directly. On the 19th of July, 1944, Operation Goodwood begins. Churchill tanks of the 31st Tank Brigade push through deep mud east of Caen. German anti-tank positions fire continuously for 3 hours. After the battle, 18 of 40 Churchills return under their own power, despite visible shell impacts on nearly every hull. Field inspection finds that most penetrations occur only at rear plates. Crew casualties are lower than any comparable unit that day. By August, the War Office revises its doctrine again: infantry support and breakthrough operations will prioritize Churchills in terrain where Shermans fail. What began as a slow compromise between tradition and necessity has become the core of Britain's armoured persistence. On paper, the transformation is visible through numbers. But in the minds of those who fought beside it, the data means survival. March 1945. The Rhine crossings near Ries and Wesel. Dawn light spreads over a landscape of wrecked bridges, flooded fields, and smoke drifting low across the river. On the western bank, Churchill tanks of the 79th Armoured Division line up beside Bailey Bridge sections waiting for deployment. Their engines idle at low revolutions, a deep, metallic heartbeat beneath the drone of artillery across the water. Engineers check flotation gear and track tension. Mud covers the glacis and skirts, dried in streaks from the previous day's advance. A signal flare rises. The first section moves forward. The bridge flexes under 40 tons of steel as the lead Churchill crawls across. Observers note how the suspension absorbs the motion, each bogie articulating independently. On the far bank, infantry crouch behind sandbags, watching the tank's slow approach. A corporal mutters, "It looks like it's climbing out of the river itself." In less than an hour, 3 Churchills have crossed, followed by support trucks and flame-equipped variants, the crocodiles. Their fuel trailers sway behind like metallic shadows. When German machine gun fire opens from a farmhouse, a Churchill pivots, its turret traversing with steady precision. The crocodile's nozzle arcs flame in a controlled burst. The engagement lasts 12 seconds. Silence follows. The infantry moves again. War correspondents record the moment on 16mm film. The footage, later reviewed by the War Office, shows the Churchill advancing through water, smoke, and mud with no visible loss of traction. The sequence becomes evidence for the post-war Army Evaluation Board. Their final report, dated June 1945, lists the Churchill as the most adaptable British tank of the war. Across the European theatre, similar accounts emerge. At Hill 309 near Salerno, a single Churchill holds position against repeated counterattacks for nearly 6 hours. In Normandy, the AVRE variant demolishes fortified bunkers where artillery failed. In Holland, its track torque allows recovery of stranded vehicles from swamp terrain. The same phrase appears repeatedly in field summaries, "could go where others could not." At Bovington, surviving vehicles are stripped down for analysis. Engineers study wear patterns on the track assemblies and drive sprockets. Most components remain within tolerance after over 1,000 miles of combat use. The gearbox housings show minimal distortion. Reports from Lulworth indicate a median service life of 3.4 years, exceptional for a frontline tank. When the war ends, production stops quietly. The last units roll out of Vauxhall's factory with little ceremony. By late 1945, many are already being modified for peacetime experiments, bridge layers, recovery vehicles, and mine clearers. The same chassis that once crossed the Rhine now carries engineering crews into reconstruction zones. Post-war assessments from Allied command in Germany acknowledge the paradox directly. The Churchill's speed remained poor, 15 miles per hour at best, yet its reputation among both allies and enemies was unmatched. German technical officers captured in 1945 describe it in reports as an immovable obstacle and the slow tank that never stops. In 1947, British armoured doctrine shifts again. The Directorate of Tank Design issues a memorandum emphasizing crew survivability, modular construction, and ground pressure ratios, principles drawn directly from Churchill data. The Centurion tank, developed in those same years, inherits its wide track base and reinforced suspension from A-22 lineage. At the Bovington Tank Museum today, one preserved Churchill Mk7 stands in the Vehicle Conservation Hall. Its green paint is faded, its steel scarred from testing. Visitors often comment on its size, its weight, and its apparent slowness. Few notice the small brass plate on its interior wall stamped with the original Vauxhall emblem and serial number. It reads simply, "Built to endure." And in that phrase lies the truth of its legacy. The Churchill never raced toward victory, it climbed toward it, one slow, unstoppable meter at a time. Busan Harbor, South Korea. The air is thick with salt and diesel fumes as British cargo ships unload vehicles onto floating pontoons. Among the rows of Centurions and support trucks stand several heavy silhouettes painted in new olive drab. Their armor still bears faint traces of wartime camouflage beneath the fresh coating. The stenciled markings identify them as Churchill Mk7 crocodiles, redeployed from post-war storage depots in the United Kingdom. The Korean peninsula presents a familiar landscape of hills, mud, and sudden weather. Reports from field officers of the 7th Royal Tank Regiment note that modern engines struggle with the steep gradients near the Imjin River. The Churchills, though nearly a decade old, perform better than expected. Their wide tracks and heavy suspension allow them to climb where lighter machines cannot. On the 20th of May, 1951, a Churchill of C Squadron tows a Centurion bogged down in saturated clay, a reversal that astonishes the younger crews. Maintenance logs from that month show minimal mechanical failures. The Vauxhall engine, once dismissed as underpowered, proves reliable under prolonged load. Fuel consumption remains high, but in Korea, endurance outweighs economy. The Crocodile variant's flamethrower system, adapted from World War II design, is used sparingly against fortified hill positions. The after-action reports describe its effect as psychological as much as tactical. Enemy forces retreat upon sight of its ignition hose extending from the hull. At the British Army Staff College in Camberley, engineers compile field evaluations from Korea and earlier European theatres. Their analysis covers 4,893 operational miles, 71 recorded combat engagements, and 18 engine replacements. The final summary reads: A-22 and its derivatives exhibit remarkable mechanical resilience despite age. Performance consistent with design intent, heavy protection, sustained torque, and superior cross-country mobility. In 1952, the War Office begins formal decommissioning. Most Churchills are withdrawn to reserve status or converted into specialized vehicles, bridge layers, armored recovery platforms, and flame equipment carriers. A few remain in active service as training models until 1956. Their hulls, still intact, are used for impact testing against new anti-tank rounds. Even in obsolescence, they provide data. At Vauxhall Motors, design archives are boxed and labeled for transfer to the Public Record Office. One engineer writes a closing memo, acknowledging the irony that the company known for civilian cars built one of the most enduring tanks in military history. His note concludes, A-22 fulfilled its brief not by speed, but by surviving everything else. In France, former German officers testify during post-war technical interrogations. When asked which Allied tank they most respected, several mention the Churchill by name. They describe engagements where repeated direct hits from 75mm guns failed to halt its advance. One report from Panzer Division records a Churchill's continuing to move despite visible fire inside the hull. To them, it was not the fastest nor the strongest, it was simply unstoppable. By the late 1950s, the Churchill has vanished from frontline service. Yet its engineering legacy remains embedded in British armoured philosophy, prioritised traction, crew protection, and modular adaptability. The later Centurion, Chieftain, and Challenger tanks each carry echoes of its frame and geometry. Today, preserved examples stand silent in museums, Bovington, Duxford, and Overloon among them. Their paint is chipped, their interiors smell faintly of oil and dust. Visitors often tap the armor, surprised by its thickness. Few realize that these cold, immobile relics once climbed the impossible slopes of Tunisia and Normandy, reshaping the meaning of endurance in armored warfare. The Churchill story is not of victory through speed, but through refusal to break, to stall, or to surrender to terrain. Bovington, Dorset. Present day. A single Churchill Mk7 rests in the museum's Vehicle Conservation Hall under controlled humidity and quiet light. Its faded green paint reveals layers of history, brush strokes from field repairs, patches welded over decades earlier. A small metal tag on the engine block still carries its factory number, Vauxhall A22, Luton, 1943. Every groove and dent tells of miles travelled not in speed, but in survival. Archival records stored nearby detail its journey, shipped to Tunisia in 1943, refitted for Normandy in 1944, modified for engineering trials in 1947, and finally retired in 1952. The tank has outlasted its designers, commanders, and almost all of its contemporaries. The documents beside it read less like celebration than audit: service duration, component failures, tonnage of steel used, and number of surviving hulls. Yet within those figures lies a quiet transformation. In its early life, the Churchill was ridiculed, labelled obsolete before its first battle. Its top speed of 15 miles per hour became a point of derision among crews accustomed to the idea that faster meant better. But history reversed that logic. The tank's deliberate pace and unmatched traction turned into virtues on terrain where others faltered. The data collected from 1942 through 1945 confirmed that reliability, not velocity, determined survival. Technical analysts reviewing post-war design archives note the tank's lasting influence. The Churchill introduced the wide-track, low ground pressure principle later applied to the Centurion and Chieftain. Its side hatch layout, suspension geometry, and modular chassis all reappear, refined, but recognizable, in British armour for the next 3 decades. The lessons drawn from its maintenance log shaped new standards for gearbox durability and torque distribution under combat load. In 1967, a Ministry of Defence publication titled British Armoured Fighting Vehicles, Technical Evolution 1939–1960 summarised the Churchill's record in understated prose. The A22 represented the triumph of endurance over elegance. In its domain, difficult ground and sustained combat, no Allied tank surpassed it. Even its adversaries acknowledged that truth. Declassified German intelligence summaries recovered in 1945 refer to the Churchill as langsam aber tödlich, slow but deadly. Their field notes document the same paradox British engineers discovered: it advanced where speed failed, and it survived where strength alone was insufficient. The machine now standing at Bovington is no longer a weapon. Its tracks are locked, its engine long silent. Yet its form remains an archive of intent, the British wartime belief that progress meant refinement, not replacement. Every inch of its riveted hull represents an argument won by persistence. For modern engineers studying its remains, the Churchill offers a clear message about design philosophy under pressure, that effectiveness is measured not in glamour or velocity, but in sustained function. It is the embodiment of a nation's industrial endurance, built during shortage, improved under fire, and remembered through evidence rather than legend. As visitors pass, the tank reflects their movement in its dull steel surface. Each reflection merges momentarily with the faded emblem of the Royal Armoured Corps still visible on its side. It stands not as a relic of speed, but as a monument to patience, the machine that proved that slow could, at last, become unstoppable.